Today I will be talking about accuracy and precision of measurements. Now, this is one of the things which are always confusing to people, and people who take introductory classes of physics struggle with it a lot. So, if you are thinking of taking introductory classes of physics and you will be, or maybe engineering, where you will be dealing with accuracy and precision, this video is for you. Now, accuracy is defined as how much close you are to a correct value of something. Okay. Now, science and physics, it's all about measuring and observing things. So that's why we're talking about measurements, and that's why accuracy, that's why precision. So accuracy is, I'm going to give you an example. Let's say I've got my notebook right here, and from the manufacturer of this notebook, I'm told that the length of this notebook is 6 inches. Okay, so that's the true value, or that is the expected value of this notebook, and I'm going to write that as 6 inches. So expected, or let's say standard, length of the notebook is 6 inches. But I'm a little skeptical, and I really want to measure the length of this thing, right? So let's say I measure the length of this notebook 3 times. The very first time I see that the length comes out to be 5.9 inches. The next time it's 6 inches. And the next time it's 6.1 inches, right? So accuracy of this thing, I would say, is really high. And how do I know that? I know that because the expected length is 6 inches, and the measurements that I did are not far away from that 6-inch length. It's 5.9, 6.0, and 6.1. All the three, 6.0 is exactly what manufacturer told me, but the other two, 5.9 and 6.1, are not very far away. So this is a very accurate measurement. Okay, so this accuracy really works in this case. Now let's think about precision, and I'm going to give you a definition of it. A precision is something that has nothing to do with the expected or standard value of something, but it has to do with how much closer are the measurements from one another. So that's what precision means. And if you think about that, here in our example where I've got 3 measurements, 5.9, 6.0, and 6.1, and the actual measurement is 6.0, and I really don't care about that. What I care about is how much closer, or how much clustered are those 3 measurements. And I'd say they are pretty close. If you take the difference of highest, that is 6.1 inches, and you take a difference of that with the lowest, that is 5.1 inches, the difference that you get, let's say delta, is 0.2 inches. That means if you take any two values of them from the measurements, and the maximum they can differ by is 0.2 inches, so they're really close, right? So that's why I would say that this is also a precise measurement. So the example that we just saw is both accurate and precise. Now it can happen that so you might see a measurement not being accurate but being precise, or the other way around. So accuracy and precision, it is possible that they are not mutually exclusive. So let's look at this example. Okay, this example is GPS. Let's say I'm watching a University of Kentucky game at the Kroger Field, and I'm right here on this stand. Let's say I'm going to give that location of mine, the exact location, because I'm sitting right there, is this. You see that blue circle? I hope you're able to see it. So that is my exact location. Now I look up on my phone at one instant, and I see, okay, I'm just going to look at my Google Map. I'm going to see where I am according to Google Map, and it's saying that, listen, you're right here. This is where you are. That right circle. This is where you are. Maybe I should use yellow. Yeah, yellow is better. Let's say Google Maps tells me that you're right there where the yellow circle is. After a minute, I see and it says, well, you are now here. I'm no VIP, so I cannot be on that VIP section. But even more, I know I am not there because I know I'm at blue circle, right? I'm at that blue point. So it is incorrect. And I say, okay, let me make the measurement one more time. So the next time it says that I'm right here. So now this would be an example of a accurate but imprecise result. This is accurate. It is accurate because it is fairly close. Those three yellow dots that you're seeing on your screens, they're really close to the blue one, which is the exact location of mine, but they're not exactly there. But they're really close. They're really accurate about my location. But let's say I use a different map. Let's say I use Apple Map. I have no problem with Apple, just for the example. And let's say the Maps tells me that, look, I tried 3 times, and all the 3 times it tells me that I'm on the pitch right here. But you see, all those 3 points, although they are far away from my exact location, that is the blue point, they are really clustered. They're really close to one another. That means that this measurement of the red points, that measurements of the location of mine using Apple Maps, is not accurate, but it is precise. Precision has nothing to do with the exact value, that is the blue point here, but it has to do with how much closer are the subsequent measurements, how much closer are your measurements. So red points using Apple Maps is an example of precise but not accurate, and yellow points are accurate but they're not precise.